Okay, so here's the last thing that we need to do. It's when you have a definite integral and you're dealing with u-substitution, okay? So here's what I recommend actually. I'm going to flash an integral in front of you here in a second. Um, do as much of it as you can. Like pause the video, do as much of it as you can, and then check back and I'll take it the rest of the way, okay? So here it is. So copy that thing down and then unpause the video when you need some help, which, well, if you should get 52/9, I think that's the right answer. So if you get all the way, great. Okay, so let me keep moving. So can you tell that the u, a good u, will be x cubed plus 1? It doesn't have its derivative perfectly in this integral, but it is to within a constant. This x squared is to within a constant. So we learned how to handle that in the last video. So I'm going to have my u be x cubed plus 1, okay? And then my du, doing 2 steps in 1 here, will be 3x squared dx. I multiplied both sides by dx there without really showing it, okay? Now, I'm just looking ahead to what I'm going to be doing next, and I'm noticing, do you see that 3? Do you see it anywhere up here? Say no, it's not there. So we learned in the last video, that's okay. You can manipulate this equation, multiplying both sides by 1/3, again, coincidentally, and that will get rid of that 3 that we don't want. So that means we have 1/3 du equals x squared dx, okay? So good. That means we're ready to rock and roll here. So I've got an integral sign here. So I've got an integral sign down here. Shazam. I have the square root of this blob here. So that needs to get represented down here. So it's just going to be the square root of u, right? And then the only other thing I haven't represented is x squared dx. Okay? And guess what that equals? Pardon me. That just equals 1/3 du. So times 1/3 du. Now, the one thing I haven't done, probably some of you noticed, is I haven't put in any limits yet, right? And so here's the tricky thing, it wouldn't have occurred to me anyway, is this. These limits are for when x is our independent variable. Have you noticed, though, that u is not the same as x, right? U actually equals x squared plus 1. So you can't expect to just plop a 0 and a 2 down here and have it make sense for u, because u and x are not the same. So what you need to change the limits, okay? And it's not hard. All you need to do is be like, okay, wait. If x is 0, I usually like to write it like this. That's a parenthesis, sorry. Okay, u of 0. So if x is 0, do you all agree that that makes u be 1? Okay, so bam. And when x is 2, u of 2, that makes u be 9, I think, if I did that right. Okay, so those are my new limits. I'm going to go, instead of going from 0 to 2, I'm going to go from 1 to 9. Bam. Okay? That's the key thing. At this point now, it basically is going to be exactly the same as the other u-substitution you've done. The new learning in here is when you have a definite integral, you got to change the limits. Okay? But let me keep doing it. So I'm going to kick out that coefficient to make it easier. 1 to 9. I'm going to call this u to the 1/2 du. Okay? And then when I do the integral of that, let's see, we'll have, I think, 2/3 u to the 3/2 from 1 to 9. Okay? Hopefully I did that right. Now I'm going to just clean this up a little bit, because this is just the same as 2/9 times u to the 3/2 from 1 to 9, okay? So this is FTC1, right? Where I'm just finding the area underneath this curve. I've done the antiderivative. Now I just plug in the top, plug in the bottom, subtract, okay? And just try not to mess up any arithmetic. just to keep this video short so it doesn't take forever to load, I'm not going to explain probably something that will be confusing for some of you. If I put a 9 to the 3 halves, that's going to be 27. If you can't see that, here's what I'm doing in my head. Do you see that this is, I got a u to the 1/2 and then to the 3rd? That's kind of how I think of it. So if you have 9 to the half, instead of u to the half, plug in the 9. So 9 to the half, do you agree that's 3? And then cube that, and you get 27. So I'm going to have times 27 minus 2/9. And then when you plug in a 1, it's just going to be times 1, right? Okay. So, whatever, I'll do it. So this is going to be 54/9 minus 2/9. And then guess what? 52/9, everybody's favorite number. So the some of you might be wondering, wait, don't you have to like change everything back into terms of x? No, for indefinite integrals, when there are no limits at all, then yeah, you don't actually have an answer that's a number, so yeah, you do have to do that translation. But when you're trying to find the area under the curve, as soon as I found my new limits here and just went with the problem with those new limits, you're good to go. So there's no changing back. This is the final answer. This is the area underneath this curve when you go from 0 to 2. Okay? So you should be able, theoretically now, to do every single problem on that worksheet. If you can't, obviously we'll reconvene on Thursday and you can ask me some questions. And good luck, all right? Bye.